Okay, hopefully you can all see that.
Yep.
Cool. Okay, so I previously did a presentation that started with a very similar slide, which was all about the talkie toaster and a little voice recognition project that I did. So, and this is, there we go. So what talkie toaster is, it's from Red Dwarf, and it's a very annoying little toaster that sits there, and whenever you mention toast, it interrupts you and asks you if you want some toast, or just generally nags you, and is a very annoying little character. But I thought it was an ideal way of learning how to do voice recognition, just playing around with that. So there's a whole other talk on that available. But obviously with when I made it, it ended up looking like this, which is functional, but not exactly brilliant looking. And I was really kind of like, well, this is fun, but it's not very presentable. But then this arrived, a 3D printer. And I suddenly thought, well, you know, I need to think of something to use this for. So why not make it a bit more interesting? Because I'm not really good with cutting things up and making things look pretty in a manual way. But I thought, you know what, if I use some simple CAD software to actually produce it, I could make a nice looking case for it. So it had to be easy to use, small, sort of like small enough to house all the bits that made up the toaster, but at the same time I wanted it as small as possible. I used Tinkercad, which I don't know if anybody's used, but it's an online CAD solution, and it was really pretty easy going to actually get into. I did try some other pieces of software before, and I really struggled trying to fathom what I was supposed to be doing, but I found Tinkercad quite easy to grasp what was going on. It's free, and yeah, you can just export out the objects files and slice them up and send them to your printer. But of course, you know, when you're designing something like this, there's going to be extra things you want, because it's a toaster and it's supposed to do stuff like it does on Red Dwarf. So the lever on one side goes up and down when it's talking. There's also visualizations on the screen. So I wanted to have a display, I wanted to have a lever movement, and also wanted a presence sensor. Presence sensor has not yet made it in. It's on the to-do list. But those are the three things I wanted to add. And of course, when you get an idea for this, you're like, oh, that display looks good. Maybe this one will work well. And suddenly you realize you bought 3 different displays. So I ended up with buying the Unicorn Hat HD, a NeoPixel 8x8 array, and the Hyperpixel 4 square, because I thought that would be really cool. And I needed to move the arm. So I got myself one of the servos. So it's a very simple servo. It just takes 5 volts ground and a signal wire. And it appears to be quite happy to be driven off a 3-volt GPIO on the Pi. It responds just fine to that in all of my testing, and they're dirt cheap. The nice thing about a servo is it's very, very basic in terms of how you drive it. So the Raspberry Pi has a couple of PWMs, and all you need to do is send it the right PWM frequency and duty cycle, and that will move the arm to a particular position. So you don't have to worry about doing any form of positioning other than giving it the value of where you want it to move to, which is ideal for sliding a toaster arm up and down. So I thought that would be perfect. So the next thing to do was, of course, actually go through and design it. So this is kind of what it currently looks like in Tinkercad. There's a few versions of some of the parts because I've tried different things and experimented. But you can kind of see you've got over here, you've got the main body, then you've got the front case, the clips on the front. These are the different holders for the 3 different types of display. This is the support clip to hold the arm that goes up and down. And then there's a couple of arms and holders and things like that to kind of handle the mounting the different parts. So needless to say, I went through lots of versions of this, and there was probably about 5 different versions of the main body, and a whole variety of other bits I've thrown away over time. So I've done all that design work, and you sit back and you let the printing commence and see what you get. And there's plenty of mistakes, but most of all, it's very slow. So the main body took over 20 hours to print, and then all the other parts added on to that. So yeah, a lot of time. And if you make a mistake, you've got to wait a long time to try your fix out. So yeah, the way I designed the servo mechanism was I had this, the idea being that this pulled on a thread and pulled down that bar there against a spring, so that way it would be pulled back up again as it released it. And you can see inside here there's a little kind of section here, and that's the bit that supports the lever that sticks out the side. So that way the lever just sits on top of this, and so when the servo pulls, it pulls that down and the lever just drops. And the code to drive one of these is, as I said, it's really simple. So what we do is we had minimum maximum values we want to work with, and we basically set up it in PWM mode, set some clock frequencies that match the frequency we want, and then just randomly assign a value in the new location bit here just to write out a random new position for it to be in, and then every so often we change that while it's speaking. One thing that's really weird about the way the pies are set up, you have to run this under root, otherwise it doesn't work. For some reason, the PWM registers aren't available as a normal user, which caused me a bit of a headache. But yeah, it's just how it is. I couldn't find a way around that. So this is where you can see it fitting into the case. So this here is the kind of little block that's on the inside of the slidey bit, and that's the bit that supports it. So the lever can be pushed down by somebody outside, and it won't damage the mechanism at all, which was kind of a key thing for me. I didn't want somebody who was pressing the outside to snap something on the inside or to fight a motor or something like that, which would cause problems. One of the other things I discovered, you can see here, you've got the little lug that snaps into a little hole there. So these are designed so that they can be snapped in and out and just hold things in place. And they're really effective, but you have to make sure you print them in a particular way. So if you look at here, you can see that the line is horizontal and not vertical, layered to and from us. And the reason behind that is if you layer them that way, these just snap off because they've got no strength. They haven't got as much strength in that direction. What I also did was I quickly realized that these little things are very good at snapping off on a larger item. So I made that mistake a few times, and after that I switched to just using the hole, and then I'd print a double one of these so I could connect 2 devices together, two components together, so they just click in and hold together. And that way, if you break it, you've spent a minute or 2 printing that, and you can throw it away without worrying about it, as opposed to having to reprint the whole of the body again, which is what happened to me. The same with these lugs. They just fell apart when I tried to mount things into them. So I ended up using these little legs here to actually add strength, and that really made a big difference. And I also trimmed out bits and pieces to make it easier to access where I could, and just reduce the material, which cut the print time down a little bit as well. So one of the things that I wanted to do is make it react to sound, and I was trying to figure out how to do that. How do I make this listen to the audio and then do something? And what I found was there's this quite a clever little tool called Carver. And Carver is designed for doing sort of EQ displays. You know, the little graphs where you've got all the different levels across it. And so what I wanted to do was utilize that to know when it's making sound, and also how to kind of do a little bit that showed the toaster was speaking. And all you do, you run Carver with this little bit of config here as a config file. And I've said I wanted 3 bars. So I've got 3 different kind of levels of that I'm tracking on normally on those kind of equalizer graphs, you've got like 10 or so, but I chose 3 because I didn't want much data. I found if I set it like that, it didn't work. But what it does is it generates this constant stream of data coming out of it, which you can then just feed in. So I've fed it into a FIFO, which is just it's a virtual device on the Pi. So you can open it like a file and then just read a stream of data coming out of it. So what I do is here, I make sure the FIFO is created within this section and get a handle on it. And then when I start Carver, I pass it the FIFO that it's going to dump its data to. And that allows me to then completely segment off the detection of the audio and reaction to it. And the data stream looks something like this. So you've got 3 different numbers that are separated by semicolons. And that allows you to, I can then use that as part of my my speech sort of reactions. So what I'm doing here is I'm receiving it back in. So this is the data coming back in. And all I do is I open it as a read-only file and then just keep reading lines out of it constantly. And then pass the value of the middle one through to update the lever in the display. So the objects I've created to manage those just react to those values and change what they're doing accordingly. So let's see if this works. I'm going to see if I can share a file. No video. There we go. It's rather unhelpfully not given me the. So hopefully you can see that.
Howdy doodly do, Talkie Toaster, your chirpy breakfast companion. Talkie's the name, toasting's the game. Anyone like any toast?
So that's the so that's a little video there of it working away. The one thing that I was disappointed with that was just how noisy the servo was. So it was kind of a bit too intrusive. So I thought, well, maybe we can improve on that. So I went and got myself a stepper motor, which is a little bit quieter. Of course, stepper motor is a little bit more complex. So as you can see here, I've had to use a micro switch so I can calibrate where it is. So what I do here is you need to use 4 separate pins to drive it, because that's how many pins a stepper motor needs. And then I use 2 pins for the switches. So what happens with that is I detect the presence of the micro switch because it has a normally open and a normally closed. So I know that at least one of those 2 pins is going to be pulled low. And I just do a weak pull up on the pins to detect it. So you can see setting up the lever, I have the pin mode set to weak pull up, and then I can just detect if either of those are pulled low, and I know that there's a micro switch attached. So then I switch to using a stepper motor. Use the 4 pins there to set up to drive the stepper motor actions. We have a slightly different range of values that we can have. And then we have to calibrate it. So what we do is we call the calibration, which is effectively move, it's up here, move the calibrate. So what we do is we move it forwards until the micro switch is no longer being pressed. And then we pull it back until the micro switch is pressed. So then we know exactly the position the stepper motor is in, and it'll stop at that spot. And then in here, we have the step forwards and back. And all that does is it goes through a very set sequence. I've not listed all of them here, but it's unique. They're typically the same for most stepper motors, but it does vary by stepper motor. But effectively, you have 8 different positions you have to drive it in to make a complete stepper cycle. And then when you're not using it, you just set everything to 0, just so it's not drawing any power sitting where it is. So it can then be pushed if needed. And I ran that. Right, let me go. And so hopefully you can hear how much quieter this is. And you'll see the calibration occur.
Howdy doodly do, Clocky, Talkie Toaster, your chirpy breakfast companion. Talkie's the name, toasting's the game. Anyone like any toast?
So there you go. So that a lot quieter, which made me a lot happier. But of course, I needed to do the display. So the one I got was the first one that arrived, which was the Unicorn Hat HD. It looks really good, but it's not the cheapest, but it's just a huge array of LEDs. And then I put a nice diffusing display cover over it so that it didn't need to particularly look sort of LED matrixy. So this is actually really easy to drive. What you do is you set how bright you want it, and then effectively you just set the individual pixels and call the show command. So it's just, as you can hear, set pixel, and you can set the brightness of the different RGB values, and then call show. So that's effectively what all this code does is just kind of manually create a nice little visual. So probably should look at what it looks like fully assembled. Which I will just grab. So that's it fully assembled. And you can see it toast.
Did someone say they wanted toast?
No.
Some nice hot crisp brown buttered toast.
No.
You don't want any toast then?
No.
What about a muffin?
Ask me a question.
Given that God is infinite, and that the universe is also infinite, would you like a toasted tea cake?
Volume high.
Okay.
Ask me a question.
Would you like a cheese and ham brabble?
So that was the completed fully assembled one, that working away. I thought it looked quite good like that. The front print, unfortunately, I didn't quite manage to get the perfect layer color change on the Talkie Toaster logo, but the actual basics of it seem to work quite well. So then obviously got the NeoPixel. Now, I confess I haven't got around to doing this one. So yeah, it's not quite there yet. Got all the mountings, just haven't given it a try. The Hyperpixel was the other one. So it's a really nice looking thing. And this, one of the challenges I hit with this is the Hyperpixel literally uses every pin on the GPIO header. There is nothing available once you've connected that screen to your Pi. And I was really struggling to think, how on earth can I use this? And then I had an idea, because no matter what I do, I'm going to use some of the pins to do things like the re-speaker for the audio and moving the motors. So all those things needed pins. And so I thought, you know what, I'm going to stick a Pi Zero onto this and configure it in OTG mode. So that's effectively what I've done there. Is you've got a USB cable running from the Pi into the Pi Zero, and the Pi Zero then runs the screen as almost like a slave device. And all I've done is I've created it as a serial connection. So it presents out as a serial device to the main Raspberry Pi running the program. So because we've used the device to feed from Carver the raw data of the audio levels, all I needed to do was update the config in the game in the main program to actually send it across the serial port instead. And then the Raspberry Pi Zero picks up that serial feed of data and can then do the visualizations off the back of it. So it's just exactly the same kind of code running, receiving the data. Now, I will confess, I didn't quite get it all finished. So it didn't really react because I was still having a little bit of problem with it. But I'll show you so approximately what it looks like. So that's the sort of the screen in place, but obviously it's not reacting to any noise at the moment. Yeah, so and then of course when I made this I had to make sure branding was in place. So the back of it shows the company that made it. Yeah, there we go. Thank you very much. Anybody got any questions?
Yeah, it certainly is annoying. You're going to sell it to a TV station?
I don't think I can sell that somehow. So just pulling up the chat window.
It must have taken you a long time for all that design. That's a lot of engineering there you did with all the different case versions and stuff like that. Must have taken you for ages.
It did take quite a while and a lot of prints and a lot of messing around and realizing things don't fit. And I still realize some things don't quite fit, but getting there. I can see. So can it make toast? No, as per the title, the toaster that doesn't toast. So sadly not. And can you make a talking car? Well, the actual code on the GitHub link, you can lift and drop anything in you like. So it takes a JSON config file to become a two-way conversation thing. So you define the keywords and then it can play back whatever audio clips you want. So you could pretty much make your own thing from the voice recognition perspective to actually physically make a car. I'm sure you can make anything in that if you want.
What kind of microphone do you use?
Well, it uses a ReSpeaker 2, which is a little two microphone board that does the audio input, and it also has an amplified output, so I can just plug a speaker straight into it. And it
does it pick up like?
Sorry.
Does it pick up kind of far, or it has to be kind of close to the device?
You can speak to it across the room, but it's not sort of an echo grade device. Unfortunately, it definitely doesn't filter out background noise as well. How much of that is down to the speaker, and how much of that is down to the fact that the audio voice recognition is not cloud based with sort of the likes of Amazon or Google behind it, is probably also part of it. You can't use their APIs for this kind of thing without completely blowing your allotment within the space of a couple of minutes. So,
and what do you use to recognize the speech?
So that's all on the other talk, but I use something called VOSK, VOSK, and that's reasonably effective. But again, if you look on the GitHub link, you should find on there all the code that does it. And I've listed 3 different methods that I tried, and Vosk came out the best out of all of them. The diffuser panel, that's actually just a 3D printed using clear filament, but the clear when you 3D print is very rarely clear. And I utilize that as a deliberate thing to make a diffuser. Toast cartridges. Guess you could put something in the top, but I don't know. Any other questions?
So I guess from all you've learned about doing this project, your next project be a lot faster, I imagine.
Well, I've learned a lot about 3D
how you do it and stuff like that. I think it's just really, really good, pretty complicated first project, really, isn't it?
Yeah, exactly. It's a good way of learning the pitfalls. I've been using 3D printers to do all sorts of other bits now. So I've been doing sort of bits to repair laser tag equipment and things like that. So all that's working quite well.
Cool.
And I've also now got loads of displays and things to play with.
Yeah. And any other questions, anyone?
Why didn't you use the HDMI screen rather than the hat? Is it just because you want to have the pixel effect, or?
So the displays, 2 of the displays I deliberately went down that route with because I wanted the pixelated effect, because the original was all pixels. The reason I didn't go down the HDMI route was more around trying to find a display that fit the dimensions that I needed and didn't go too large. The problem is that a lot of the displays the dimensions were awful, because the new modern kind of 16:9 means that you end up with a screen that's about twice as wide as you need it, which makes it really hard to fit into the device. I couldn't find a square HDMI connected device.
Those hyperpixels actually provide you access to the I2C bus on the back of the hat.
Yeah, I think I needed some other pins as well, though. That was the problem. It was like I2C just wasn't enough on its own, unfortunately.
Yeah, yes, looking at that as well, I thought, well, maybe I can hook up a different hat, I2C hat, to do something else. Anyway,
I could probably do something like chuck on an I/O expander to deal with the motor side of things, but I think the re-speaker needed it's got a couple of other inputs that it needs, so kind of blew that one out the water.
Yeah, I found it quite frustrating when I bought my hyperpixel as well. It's like, well, there's no pins, can't do anything.
Yeah. Hence going to the OTG method.
Yeah, cool.
And your re-speaker, is that, you've not ported the microphones out for that, have you? They're just now within the case of the toaster.
Yeah, so they're actually in the top.
So they point out the toaster slot. The toaster would be the bread slot.
I'm just going to stop sharing that for a second, and then hopefully you can see it's just shining through there. The little microphones are there at the top, which it does an okay job. I don't think it's as good as if it's just exposed fully. And I did experiment around with trying to put it sort of forward facing with something to let the microphones see through, but it just became a bit of a nightmare from how do I mount this? How do I actually make it look aesthetically pleasing from the front with speaker grills in there? It didn't work so well.
And just a sort of common thing that I've seen with screens, and just looking at your meterage app on some big kind of audio mixing desks, in order to make the meter bridge a narrow letterbox thing at the top of the console, one of the well-known manufacturers does use a 16:9 screen, but just leaves the other half of it inside the console, which is great when you need to crack it open to work on it because it's a good light source. But 99% of the time, there's literally half the screen in the bottom of the box that's just doing nothing.
Yeah, it is very frustrating, but there's just nothing I can. I just was too space constrained to utilize a lot of the ones that I looked at. I did actually get one of the proper Pi displays, but it just, yeah, no way to fit it in.
Have you got a red LED inside it to make it look like it's working as a toaster?
It does have some LEDs in it, but I don't, not to that quite effect.
Excellent. Thanks very much, Michael. That was really great.
Yeah,
Enjoyed that one.
really good.
A bit shocked how complicated it was. Well done.